uses this term, and now it's become quite common as well, to distinguish AI between these two categories, predictive versus generative. Predictive, again, the supervised learning techniques that we just talked about, making predictions, and generative AI, which is the more recent ones that we've seen in the last 2 or 3 years with ChatGPT and so on. The conceptually, right, I'm going to give you a 40,000 foot view of how these are different. But before that, I do want to note that the consensus, at least today, in industry and research is that when we talk about AI in business, a lot of the value that's happening right now to businesses in using AI is coming from predictive AI, right? And that tends to get ignored because we're all very obsessed and excited with the generative AI piece, right? And it's hard to quantify this, but anecdotally, people have used 80%, 90%, right? Numbers like this, but essentially to signal that, look, a lot of the value that businesses are getting from AI today are coming from predictive models. So let's not forget that, right? Let's not ignore that, because those are still very important components of how we can add value to a business. That said, there's also consensus that most of the growth is coming from generative AI applications, right? Which is why there's a lot of interest and buzz about Gen AI itself. Conceptually, again, at the 40,000 foot or 50,000 foot level, the difference between these two is that the predictive AI piece is going from data to make predictions, right? So think about data as a credit card transaction. A prediction is the transaction fraudulent or not? Generative AI, on the other hand, is designed to go from data to more data. In other words, these algorithms are necessarily designed, if you give it data of a certain type, these algorithms are designed to produce more data of that type. If you give it lots of documents, lots of sentences, it learns to produce more sentences, more documents. If you train these models with lots of images, it learns to produce new images. If you train it with lots of PowerPoints, it can produce more PowerPoints, right? And by nature, these algorithms have been designed to produce new data, like the data that they're trained on. But because by nature, they're designed to produce new data, it's important to understand that when these models so-called hallucinate. Sometimes I tell people, my students, that this is not a bug, it's a feature. These are models. If the only thing that these models did was to regurgitate the training data, these models would not be interesting today. They would in fact be the same as Google, right? They'll give you something in the historical data set. What makes these interesting today is the fact that they generate new information, right? And the same algorithm that's generating new information sometimes has a hard time figuring out when the new information is quote unquote correct and when that new information is quote unquote wrong. It's not the algorithm's fault, but it's a feature of how these algorithms work. Now, that doesn't mean that hallucinations is a good thing and we have to accept it. We have ways to manage it and put guardrails around, which we'll talk about a little later. But I did want to point that out because when we understand generative AI, it's important to understand that these algorithms were designed to produce new data from similar looking data. Here's an example that gives many of you the context of modern Gen AI. Right? ChatGPT-like models have been trained on millions of documents, right? Wikipedia articles or stuff that you find on the internet. And by ingesting all these text, these Gen AI models can then make predictions on what word could follow a sequence of words, right? So you have a lot of information that's fed into these models. And the model has a fragment of a sentence or a prompt that starts by saying, Mary woke up from a deep sleep to stare at A. What should be the next word, right? And so these models are very good at predicting the next word and keeping on going in sequence to generate the kinds of information that we see. I do want to ask you all to reflect a little bit about how this magic has happened, right? So, again, I tell my students that we should not be thinking of AI as magic. We should do our best to understand the capabilities, because only when we know how it's generating the magic will we understand what it can do and what it cannot do. The predictive AI context we understand extremely well, because these models look very similar to statistical models for prediction that the business world has been using for a really long time. Generative AI is newer, and the kind of magic that it's producing is taking everyone by surprise. And so I do want you all to think a little bit about how did this happen? What was the underlying ideas that made ChatGPT come to life 3 years back? Why did it not come 20 years ago, right? There are many reasons, and I will point to two that I feel are particularly important. But of course, you will not have consensus on what are all the reasons why ChatGPT is what it is today, or it's the family of these models. The first one is something very technical, but super, super important. Right? These are called embeddings. And the reason why these are important is almost all machine learning algorithms, and in particular, the kind of machine learning algorithms that are used in AI models are called neural network models. Neural network models, I ask my students to think of this, they simulate artificial neurons, like how the brain works and so on. But you can think of these as numbers to numbers machines. They learn if you give it pairs of numbers and tell them that these are related, and if you give these models hundreds of millions of such pairs of numbers, they'll learn how to predict output numbers from input numbers, right? So the input to these models are numbers, the outputs are numbers. These are numbers to numbers machines. Why am I harping on this so much? For these models to